Hello everyone, welcome to Practical GCP. Today's topic is about real-time analytics with Cloud Spanner CDC. CDC stands for Change Data Capturing. It's a technique typically used to get data out of the operational databases by tracking all of the changes in the form of events. This is an important topic because it allows you to get access to real-time data in the form of events to build advanced analytics systems and pipelines. I'll quickly go through what is Cloud Spanner and what are the common use cases and when you might want to use Cloud Spanner. The fake t-shirt drop is an imaginary application I've created. I've got a database design, I can show you that. So the purpose of that is that you can actually see a practical use case, look like the real thing, and then to see how the CDC solution works in that use case. And I'll explain what is the need and why do we need the real-time analytics, right? And then why is this important? Followed by the explanation of how exactly the Cloud Spanner CDC works. As usual, I'll do a demo followed by pros and cons in the summary. Okay, what is Cloud Spanner? It's actually really simple. Cloud Spanner is a relational database. Right? It's basically a relational database, just like what you would use in the old days, like a MySQL, Postgres. It's the same kind of thing. It offers strong consistency, high availability, but one thing that is quite unusual and very powerful is it offers horizontally scalability. This is very, very useful for mission critical applications. So if you look at this table, right? So I've circled some of the red areas where highlights the differences of Cloud Spanner compared to some other traditional databases or the non-relational databases. So if you, in comparison, you can say it's a SQL database versus some of the non-SQL databases like Bigtable and Datastore. And this supports strong ACID transactions. So those ACID stands for atomacy, consistency, isolation, and durability. This allows you to serve very, very high concurrent workload without worrying about data consistency issues. The scalability is a very important thing because Cloud Spanner is a horizontally scalable database. What that means is it's not constrained to such as the old way of having a big machine that's called vertical scaling. So you basically make the CPU, give it more CPUs, make the node bigger, and give it more RAM. But then you'd typically have a limit on how much kind of data or compute or memory you can scale it to. With a horizontally scalable database, you literally add more machines, right? So the scalability is close to infinite. So this is what horizontal scalability is. The availability of the Cloud Spanner is one of the main selling points. Compared to the other relational databases where you have the failover, you have to set up, the replica databases to reduce the downtime. Whereas Cloud Spanner manages that for you. You have the 4 nines, I believe, for the regional Cloud Spanner database. And then for the cross-regional ones, you have the 5 nines, which is extremely high SLA. Right. So when do you actually want to use Cloud Spanner? So this can actually vary a lot, but traditionally, or even kind of nowadays, you probably want to use it for something mission critical, right? So something that you want to collect data, you don't want anything goes wrong. You could have a highly concurrent use case. You have lots of users from the front end, from the game server. You see, this is a use case that Google gave as example for user profile and entitlements. So this could have a very, very high and complex logic to manage the users, the profiles on the servers. So you can have the profile, the player's profile, the inventory, and so on, right? So the backend database and Cloud Spanner is a very powerful use case for this kind of use case. So you can have lots of different kind of combined operational traffic where a Cloud Spanner can interact with that. And then this is where your main operational database, you can see it like that. And one thing I want to also add is because this may change the idea of a lot of you on when you actually would use Cloud Spanner. in the past, Cloud Spanner used to be quite expensive, but I think this has been going on for maybe a year or maybe even 2 years. That you have this thing called the processing units, right? So it's actually quite cheap to actually use Cloud Spanner as your main database. Even your use case isn't about something requires extremely highly scalable throughput or use cases or transactional workload. So the starting cost is actually $0.09 per hour. So I did a bit of math. If you have 100 gigabytes, right, of storage requirement, this can go for the 100 compute core into something like 400. But the starting price is just over $100, right, per month. This is actually really cheap for a database that you don't really need to manage much at all. It's almost like serverless, although it's not serverless, but it feels like that because it has a UI, it has everything. You can easily set something up. You don't need to manage, network or IP addresses. It just works, and then you interact with the APIs. So this might actually change your mind because it's been going on for a while. So I think this is quite important to consider when you choose a database and what is actually the easiest way for you to get started with something, right? So this is the fake t-shirt shop applications backend. It's actually quite easy. I've actually made a very simple design, but it does have all the building blocks, the key building blocks. So typically, let's say you're a t-shirt shop, right? You have categories, right, of the product you want to offer, like the kind of t-shirt you've got. And then the categories will be stored in this category table. You have products that reference the category ID, that you have the product ID, name, description, price, and maybe image for the products. Then you have customers, right? The customers can place orders, which has the order ID and a foreign key as customer ID because that is each order has to belong to a customer. You have the order date, the amount, the shipping address, and the billing address, right? And then each order would also have a number of items. So that could be one or multiple items in an order, which will subsequently have the foreign key as the product ID and the order ID. So this one kind of refers you to exactly what product you've actually have in each order. So this is kind of a very typical relational database design that you can put into Cloud Spanner. Okay, so let's have a look at why. Now I have the database, right? Now I have the fake t-shirt shop. So we have customers buying a t-shirt from this website, this e-commerce website, and then they place orders. This order has order items. So, okay, there's lots of stuff going on. And imagine this is just the first version of it, right? This can get a lot more complex over time. But typically what's going to happen, so today's world is very different to the old world of monolithic. You don't really build everything in the relational database, which is where we have the Cloud Spanner here. So this is actually where the imaginary fake t-shirt shop runs, right? It's all backend is this Cloud Spanner database. The issue today is in order to fulfill the increasing business demand, to be very smart about the decisions you make, such as you want to retarget customers, you want to have lots of different services managed by different teams to scale a lot faster, to build things a lot faster. You can't really build in here because as everyone knows, monolithic, as things become more complicated, is a pattern that would no longer work. So what if there's a way to get all of that data out in real time, including all of the changes? This is basically the CDC solution we're talking about. But I want to go through some of these use cases. You can see why I'm actually talking about this and why it's actually important. So the really simple ones, actually what everyone does today is having some sort of analytical database on Google Cloud. You have BigQuery and you have some sort of a BI reporting system such as Looker or Tableau, and then you want to do reporting, right? A lot of the times, especially from a past, I would say even like 6-7 years, the daily stuff or even hourly stuff for reporting is just not good enough. There are certain things such as, when an order came in, you really kind of want to look at some of the behaviors as you as you just see fit, right? So typically the business demand is like, I don't want to wait for an hour to see the stuff. Whenever I want to get to on the website, actually on the BI platform, I want to see exactly what's happened, right? Because I might just had a sale like 20 minutes ago. I want to see how it's going in real time. So with the CDC solution to get the data into BigQuery, that would enable the BI use cases in such way. The more interesting one is where it gets into a message queue. Pops up is the typical ones you would go to on Google Cloud, because it has a lot of native integrations with other services such as Cloud Run or BigQuery as well. So now we have pops up. This is where it gets interesting. If you look at the three distinct use cases, this is actually the one I see quite common in most businesses. One, you would have some sort of API in here, right, to serve the users basically on a website to show the individual orders they've made, right? Think about some of the app's order page where you see the previous orders and whatever. So, and then what you can see here is, if your data comes in real time, you can actually put that into the data storage, which is just, you can use as a read-only document database. You don't need schemas. And then this can actually serve the read-only traffic for the users in a completely separate microservice. What if you some of this use case, you need some relatively complex aggregation, right, to give some sort of report to the users, but then you need this to be real time as well, because you don't really want to see this being out of date, right? Because if something just happened, you're just losing the most recent area. So this could be for users. The users could be the customers, or could be your own website that you have some of the reporting page for admins. And then this is where you can use Bigtable to do the aggregations for the real-time data, where the real-time data coming into Bigtable in this case. But also there is the most useful one is there's some of these retargeting use cases. So you can react based on certain events. Let's say an order has changed, right? If someone updates the order, if someone canceled the order, you might want to do something based on that use case, based on those events. So those events that come in, you would say you probably would already have a user profile, right? So that can be in the Vertex AI endpoint, or you can use another Cloud Run service to basically surface the models that you can use for predictions. Then based on those events, you can say, okay, based on the customer's profile, you might want to predict and then retarget to the customers or prevent them from churning. So there's various use cases in here. This is where the ML use cases come in. That is super powerful, but you need to have real-time data. And in a lot of the cases, if you wait for an hour or two, sometimes a day, with the batch processes that runs, it is too late, right? So this is why I want to talk about this topic, and the need for real-time analytics is so critical these days. Right, now let's dive into the actual how the Cloud Spanner CDC works. It's actually quite straightforward. There are a few components you need to understand in order to use this thing. So I will have a few links I will supply in this video that you can read about. But there's few key components you need to understand, and in order to deploy this service and make sure it works for your use case. So first of all, Cloud Spanner has this thing called the change stream. This is part of the Cloud Spanner service. So initially, when you go into this UI, you can't actually see the change stream section. But as soon as you deploy one, you will see this coming in, right? Change stream is actually quite interesting. I'll talk a little bit about it now, and I will show you what are some of the options I've used in this use case. The change stream you can apply for a number of various options. So the one I'm using, you can see, is everything, right? What that means is you have a database in Cloud Spanner, right, which has the 5 tables I've created in there. You literally track the entire database. So what that means is whenever something changes in that database, it doesn't matter which table, doesn't matter which column, and it will all go into this change stream. There are also other options. You can do a table level tracking. You can even do column level tracking, right? There's various ways and granularities you can configure this thing. So makes it very, very useful. So if you have a very large database with very complex stuff, you may not want to track everything because it might not have enough value and it could get quite expensive in the in the data transfers in here. Then you may not want to have everything, but the option does exist if you just want everything. This is the first component. You need to set up your change stream before you can actually get into the data flow part. The data flow part is actually, there are 3 data flow flex templates that's been created by Google already. You can actually deploy this using the gcloud command. There's actually quite straightforward because these are 24/7 jobs that runs to do the real-time streaming, right? So typically the way it works is you deploy this data flow template, it runs 24/7, you attach it to the change stream of Cloud Spanner, and this will basically listen to all of those changes in the change stream and then apply those, track those as events, and then apply to those other systems, right, from this data flow template. So this can go into BigQuery, Cloud Storage, and PubSub. The one I will show you today is PubSub because I think that is where the real power is. So this is actually really simple because it's a predefined template. All you have to find is the is basically the data flow template already been packaged in a GCS bucket, and then you deploy it. You supply the change stream in the Cloud Spanner database, you supply the PubSub topic, and it just works. So there are other options in there, but I won't be focusing on those today, but you do know they exist. Okay, let's jump straight into the demo. I'll start by showing what I've actually got in the database, right? So this is the Cloud Spanner database. As you can see, I've created this e-commerce product database that is part of the fake t-shirt database instance, right? So this is the database, this is the database instance. So now it's created, I have 5 schemas in there, which is the ones I've shown you with the categories, customers, order items, orders, and products. So, you can see now it's already showing up, it's watched by everything stream. This just basically indicates that the change stream is active. And this interface is quite powerful because you can see on the left hand side there's quite a lot of options that you can deal with. Let's say if you want to look at categories, right? So you can see the schemas here, and then more importantly, you can go to Spanner Studio. This is where I was saying, like, you don't typically get this kind of stuff in a browser, but Cloud Spanner I feel is really elegant to use. You can see the tables here, you can see the schemas, right? You can see the indexes if there's any. I think I do have one in the customer side to have a unique index on email. You can see all the primary keys and foreign keys and everything, right? So if you look at the schema here, one thing I do want to cover is because Cloud Spanner is a horizontally scalable database, it doesn't have the concept of a primary key that is an integer that is auto increment. That is actually a really hard problem to solve in distributed computing. So instead of doing that, the recommended best practice, and actually a much better way to do it, is to, rather than using an integer, is to use a string. So in this case is a UUID4 format that is 36 in length. So the way this works is this is a schema, right? And it has the primary key, and then you can actually use a default that will generate the UUID for you. So in this case, you can see that when I select this one, because I didn't actually use the one, I actually used the fake data generator and actually made a mistake. I used the hexadecimal version of the UUID4, but this column is basically a string column that is a UUID that is randomly generated, that is horizontally scalable as a primary key. So basically that's what it is. So just keep that in mind while you're looking at all of these tables, because it's all the same. If I look at products, right, you can see the product would have the same thing. Again, this needs to be corrected as not a hexadecimal, but as actually just a UUID4 to store in the database. You have the name, description, these are all randomly generated data. I'll share with you the code I used to do this. It's actually quite useful because it's something I wrote to basically, you can wipe the whole thing, generate everything from the scratch with all the foreign key constraints applied in the right order. So you can actually see how exactly this is going to work with all the referential integrity you require. So now you have all of these tables created, right? So I have this table created. I've got the schemas, I've got some data generated, and then this is basically the starting point. And then what I've done is I've created the change stream. So the change stream, as you can see, is here. That tracks the entire database. And after that, what I've done is basically to create the pub subtopic. This pub subtopic is the one when I deploy the data flow job, as I showed you in the diagram, it tracks the changes from the change stream and it will send it to the pub subtopic. For convenience, I've created two pub subscriptions. This one, the data goes into BigQuery, right? And then so we can actually see all of the changes being tracked in there. It's actually also a very useful thing as well, because if you actually deploy to PubSub, you can basically track all of these changes in BigQuery for downstream consumption as well in the analytics space. And this one is basically the change stream for a normal pool subscription, which I will show you when I run the script. It's basically the use cases where you can run in the Cloud Run service to basically consume those, or the Cloud Run jobs to consume those, depending on whether it's push or pull. This is the data flow job, right? So once you have all of these things in place, you can deploy the data flow job. You can see I'm getting a bit of traffic in here, right? Whenever there's a change that happens, this basically monitors all of the changes. This is the deployed from the template, and then you see the output in the BigQuery. Okay, so now let me show you something. If I go to the database, right, I think I may have an example in here. Look, I've got this one, right? So I mean, this may not be the right ID, but let me just have a look at something. Right. If I look at the categories, right, I've got these categories. If I pick up one of those IDs and then apply it to here. Okay, before I do that, I want to do two things. One, I've got this script that I can run. So this is the demo PubSubs consumer. So what I can do is I can run this now. So you can see it's listening here, right? This is running. No messages yet. No change event has happened. If I go back to BigQuery, so the last one that came in was 2304, right? Now it's much later than that. So what I'll do, I can run this again to make sure there's nothing coming. Okay, there's nothing coming at the moment. So what I'll do now is to run this script. So what this is going to do is to update one of the categories name based on a category ID. Okay, so let's try it. If I apply this one, so now one row has been updated. So what should happen is in here, I've now received the message. This is the message payload, right? But it's not easy to see, but this is basically what comes through the pool subscription. But if I go to BigQuery, and then if I just grab this whole payload, this is the one that just came in, as you can see. If I just grab this whole payload, go to the IDE and do a bit of formatting, so you can see, right, you can see this is a small message, right? Not as big as the one I've shown you, has all of the metadata you need, but where it comes to here, you see a modification type that is update. This is where it gets really interesting. You get the key, right? You get the new value as well as the old value. This is super important because it depends on what you want to do in your downstream data pipelines, or how do you consume those events. You always have the previous value and the new value. So you can do, if you have your, if you want to detect based on if certain changes has happened, right? And then you can actually do this directly in the message rather than persisting this somewhere else with the state. So this is very useful stuff. But you can see this, you can see what I mean, right? So now you have different subscribers. One is this is basically in the consumer, and then the other side you have the a different one that goes into BigQuery. So these are basically tracked via the data flow CDC process via the change stream, and then go immediately into your PubSub message queue or the BigQuery table for whatever use cases you need to have. Because this is indeed very, very powerful. So let's look at the code, because this is quite important. A few things I want to go through with you. So first of all, let's look through the README. I described how this thing was set up, but all of the details are here if you want to try it out. So this is the everything stream that I've created in the Cloud Spanner. You just need to apply this to your database. And then for all basically means the entire database. As I mentioned, there's different kind of options. I'll attach a link on what these options are, and then you can decide which one is the best for you. Obviously, you need a topic. This is where I created a topic. This is the BigQuery table for the CDC to go to. I prefer to look at in BigQuery because it's just a lot easier for me to debug them or unpack the messages, to format the messages. But this is basically a generic format of the BigQuery subscription from PubSub. Yeah, so this is the subscription I've created. So actually, then whenever the message comes in, this is what I can see in BigQuery. So the last part in here is the data flow job. I've given you all of the information you need, and also picked one of the release candidate. Please make sure you don't use the latest version. Latest, I mean, there's a latest folder, but don't use that. Because if you do that, then if there's anything changes next time the data flow job gets deployed, it might break your pipeline. So always choose the one that is in an actual time-stamped binary, right? Not like something that just dynamically changes. So this basically allows you to specify the Spanner instance ID, the database, the metadata instance ID, the metadata database, and then also the PubSub topic. So there's one thing very important here is you do not want to use the same database as your operational database to store the metadata for this job to run. What this means is if I go back to here, right, now you can see I have two databases. This is my e-commerce fake t-shirt database, and this is another one I've created. This one is only used, right? This one is only used for tracking the metadata. So you can see this is just a database with a schema the data flow job requires. So when you deploy the data flow job, it will need somewhere to track the metadata. So this is where it uses. So the biggest reason that why you don't want to put this in the same database is it can affect the performance of your operational database. But the thing that's more annoying is if you put this in, and then you track the entire database, this thing would become a loop, because whatever you do, then whenever the things gets changed in there, it will actually from the data flow job, it will write back into the Spanner, and then it goes into the CDC, which is not great, right? Because you don't need it. Anyways, that's the two things that you want to keep in mind. Okay, so now we've talked about the README. Let's go into the schemas. The schema, I've actually created the whole thing in sequence, in the right sequence that where they should be created, because there's foreign keys and constraints in there. There's a few things I want to talk about in here. First of all, I didn't use the Postgres SQL. I've used the Google SQL. There's a number of reasons I want to do this. One is because in these scenarios where I need to use interleaved keys, I can do another talk about that specifically, but basically if you do things like this, which are foreign keys, where you may, let's say if a customer can place a lot of orders, and when you search orders, you always need a customer ID. So the data is not co-located on the same node. So what that means is the performance can hit if you have very, very high traffic. But if you don't have very high traffic, it might not cause much of a difference. So something you need to test out. But for me, first of all, I like the simplicity of the Google SQL. And two is I also prefer to not lose the ability to use interleaved keys. So that's the main reason I chose this. But you could, if you're more familiar with Postgres and you don't have very heavy traffic workload, you could use the Postgres, which support a lot more data types than this one as well. But I've chosen to use the native Cloud Spanner SQL, which is the Google one. But yeah, that's the schema in there. If you want to try it out with this, you can try this as well. Back to here. So one thing I've done is, if you wonder where the data came from, is I've created this generate test data script. So what this does is it uses the Faker library to generate a lot of test data, such as the one for categories, the one for customers, one for products, the one for orders, and then the order also has sub-orders. And then I've created a few helper functions to basically allow you to map this correctly and making sure the referential integrity with the foreign keys is correct. So it actually inserts the data with all of the references in the right place in the right order. So, but that's what this script does. So what you can use this for is you basically can delete everything, generate all of the test data, insert the test data, and then this is very good for you to test the CDC stuff. This thing is still running, but if I actually show you this script, right? If I run this thing, what's going to happen is it will drop everything in the database and then it will reinsert everything. Okay, I just want to show you delete one. You see the script I just showed you. I've deleted everything, right? First of all, and then I've inserted everything back. So the deletion is also part of that gets tracked in CDC. This is very important because if you see something's been removed, you can see the new version is empty. The old version is where it has the order, right? So this allows you to track whatever you want to build downstream. You can see if anything's been removed, you can use the delete to track all of the deletions as well in those messages. So it's not just additions or changes, but also deletions. So basically anything that happens to the database in the changes. Okay, I think that's everything I want to show you and everything I've got. You've got the demo consumer if you want to try out to subscribe to the other one, to build some apps using this, but this is pretty much the solution. Okay, let's do a summary. I think because it has the real-time change data capturing for the entire database, you can do it on a database, you can do it on a column level, you can do it on the table level. It has a lot of flexibilities. So this is actually very powerful. You can actually track anything you like in the database. I think in a lot of the other tools, I don't think it's actually this flexible. This is actually something I really liked. Also, initially, I thought the data flow template is actually quite tricky to deploy, but then when I actually tried it, it's actually quite easy because these are all pre-built. So you can actually just use it with a gcloud command and you can deploy it and it just runs. It's very easy to manage. I've actually tried all sorts of different use cases. It didn't seem to actually break anything. So it looks like it's just a simple thing to basically replicate the changes from the database into PubSub in this case. So I really think is, with the only over $100 per month cost that you can get started with the 100 compute unit, you can actually do a lot of stuff. I haven't actually load tested how much you can do, but in terms of development, if you have test servers, you have integration tests, you have all of this stuff, the cost for other type of databases could be quite high, right? So this one is actually quite cheap. So you can actually start a lot of these things with only 100 compute unit, the processes, which, as I mentioned with the user interface in there, that you can do most things in there. It has very little infrastructure to manage. There's no IPs to deal with. And I think for me is the ideal choice for relational database if I want to use it, because it's just so much easier to use. One thing I would think would be better is, it would be nice if the CDC solution is more integrated. What I mean by that is it just feels a bit, compares to the other tools such as the ones like Fivetran and the other ones, they're more geared up for the CDC solutions. This one, it seems like, Google have data stream. I don't think it works with Spanner. Maybe I'm wrong. But then you've got Data Fusion, which only probably does batch. You've got Cloud Spanner creating the change stream, but doesn't actually do the work to get data streamed into other places. So obviously, I understand the separation of concerns. You probably don't want to bake into the Cloud Spanner servers, but I think ideally, if there's something you can easily, just integrate without actually going to all of these different places to deploy, that would be, I think, a lot better for the enterprise clients, in my opinion. So just an idea, I think, although the Cloud Spanner may sound like something you want to use for really critical use cases that are very high traffic, very high throughput, very high concurrency. But I think if you build internal apps, for data collection and management, there's nothing wrong with using this, right? So especially, there's two ways you can get data from Cloud Spanner. One is you can use the federated table. If it's basically analytic use cases, you just want the latest version of everything in Spanner, you can use, you can mount basically Cloud Spanner tables into BigQuery as external tables. And if you use Analytic Boost, that doesn't even actually affect your operational databases, right? Or you use the Spanner CDC solution to get data from there into your other, systems as well. So you have both options too. So I think for data collection, especially where usually these things are probably done in Excel these days, for I think because of the cost is very low, what is the problem of using Cloud Spanner for this? It's just an idea. Let me know what you think. But anyway, that's everything I have for today. Quite a long details with lots of things I'm quite excited about with the CDC solution of Cloud Spanner. But thanks for watching. I'll see you next time.
Go out!